Hi guys, this is the last topic of rotational dynamics, the angular momentum, and this part, along with angular momentum, I'm going to take also the rotation. It's very important. Sorry, rotation, no, it's rolling. It's the most important topic. Both angular momentum and rolling, the often the questions are asked. So you should have some basic knowledge in all these topics, and they have some quite few formulas we are going to apply. Most importantly, have some conceptual knowledge. If you have that, then you can easily crack each and every question. So let's see what is angular momentum. What's an angular momentum? Just a quantity of rotation motion. It's just a quantity of rotation motion is said to be as angular momentum. Simply, a momentum is said to be as a quantity of motion, and there is a straight motion or a motion in a plane, a motion in 2D. It's simply called as motion in 2D. It's generally called as momentum, where we measure some quantity. The quantity of motion is referred to be as momentum, but quantity of rotational motion is said to be as angular momentum. Here we have some few formulas for angular momentum as what we have discussed for the inertia. Same like that, we are also discussing formulas for angular momentum, and similar kind of questions were often repeating. Let us just denote a symbol for angular momentum. Angular momentum, we just have used the symbol for angular momentum as L vector. It's also a vector quantity. I'm just using that L vector. You already know the momentum of linear momentum. Linear momentum is a momentum where there is we often seen in 2D. This linear momentum is referred to be as p vector. What's the difference? This angular momentum we just used to see in rotational dynamics. Linear momentum we just use in 2D. So about the axis of rotation, this angular momentum L vector equal to R vector cross product P vector. This is also a cross product. We already discussed that inertia equal to R vector, sorry, it's not a inertia, sorry, I just torque equal to R vector cross product F vector. We already discussed. You have to know a different names. In the questions may try to confuse you. Here the another name of torque is moment of force. What's that? Moment of force. They may try to confuse you with these terms. You often hear the torque, but when they try to confuse you, they might be asked the question, what is the moment of force for this question? Likewise, they may be asked. You just don't need to confuse moment of force is referred to be a torque. Same like that, for angular momentum, you have some another name that is moment of momentum. What's that? Moment of momentum. That's what. Same like that, it's a cross product, it's a R vector and a P vector. Okay, where R is the position vector of P with respect to the axis of rotation. It's just a position vector. We already what we discussed for a torque, same like that angular momentum. When you go for a questions, you have some very good idea about these things. Let's see. I'm just moving forward. I simply make I what I already discussed that torque equal to F or sine theta. I already know that this is a formula we are often using in a previous topic. Same like that angular momentum equal to P or sine theta. We already know that what's the formula for linear momentum. We just already knows that it's a product of mass into velocity. This for a formula. I'm just putting these values here. MVR sine theta. This for the formula. You have an idea about it? This was the final formula. Just when I have theta equal to 90 degree, this formula seems to be MVR. That's it. Let's move on to a question further. Before moving to question here, you have to learn some other formulas also for the angular momentum. Just we discussed before, the another formula of torque equal to I into angular acceleration. This was the formula I have discussed previous. I think so you just seen my previous video. I have discussed all these topic and I also solved the question regarding these formulas. So you have any doubts, you watch my previous video. I have discussed a clear idea on torque. Same like that, what I have discussed for the torque, here also for angular momentum, we also add another formula. What's that formula is I into omega. This is what? This is a very important case. We already discussed that this is a case for non-equilibrium cases. What's that? Non-equilibrium cases. This is also formula for non-equilibrium cases. As like that, the angular momentum, and under the non-equilibrium case, L equal to I into omega. Okay, omega is an angular velocity. So you got a very good idea about this. Just move on to a question, so you may get an idea how the questions are asked in these topics. Here, the solid sphere of mass m and radius r is rotating with omega above the center. Find the angular momentum about the axis of rotation. This is what the question. The solid sphere of mass m and radius r is rotating with omega about center. Find the angular momentum about the axis of rotation. Here they just asked what's the angular momentum when this rotating about its axis. Just see, I'm just this is a sphere. This assuming this to be a sphere and it's rotating along its axis. I just want to find here, I need to find the angular momentum. This was the question. Given that radius is r and mass is m, I just want to make to find angular momentum of axis of rotation. We already know that what's the formula for angular momentum under a non-equilibrium case, that is I into omega. In the first video I have discussed inertia for different rigid bodies. Suppose this question is said to be that this body is a sphere. We already know that inertia for a sphere about its axis is 2 by 5 mr square. You don't forget these formulas. These formulas are very important. You keep on revising these formulas, then you'll never forget it. So just I'm going to apply it here. 2 by 5 mr square into omega. That's all. We just find the answer of for this question. It's a simple question. It's never going to ask in your need, but for a board purpose I just given this. You may get some idea about it. Suppose I just try to confuse you. How I am going to try to confuse you? This may be asked in your need questions. Find the angular momentum. In the previous question, in this question, they said that about its axis of rotation, you find it. This was the question about the axis, about the center on its axis. You need to find this for the question. I asking you the question was that what's the, if I'm just changing this question, the solid sphere of mass m is the same. Changing this question, radius is rotating with omega about its center, but I'm changing here instead of center I'm just making here that tangent. Okay, it's about its tangent. Find the angular momentum about its axis. Now in the question I just change, it's not a center, it's a tangent. So what can I do here? This seems to be like tangent. I already knows that along the center, so rotation is 2 by 5 m r square. This was the inertia. In order to find along its tangent, I can simply use the formula parallel axis theorem. What's the parallel axis theorem? That in this assumed to be the I dash. This I dash equal to I naught is along the center of the axis plus m into distance square. What's the distance square? What's the distance here? R. So just I simply make m r square. I already know the I naught. What's the value of I naught? 2 by 5 m r square plus m r square. What is finally the answer was 7 by 5 m r square. This was the final answer to me. I dash. When I know the I dash value, I just simply makes that L equal to I dash into omega. This I dash, I can put these values 7 by 5 m r square into omega. That's all, I get the answer. I just simply twisted a question and just changed a simple word. Instead of center, I use the word tangent. By changing the word, you see that how this formula is going to change. So when I was solving the question in rotational dynamics, you should have a conceptual knowledge. Then you can easily do whatever the questions are asked. So guys, angular momentum is that's it. You go nothing is just to be different. I'm just going to discuss another formula. What's the Newton's second law? What's the Newton's second law? The Newton's second law is a law of unbalanced force. Law of unbalanced force. He tells that force equal to change in momentum with respect to time. What's that? Force is change in momentum with respect to time. I just differentiating it out, you see. I just momentum what's the formula? M into V. Suppose mass seems to be a constant, just taking out dV by dt. What's its changing velocity with respect to time? Mass into acceleration. This is what you know that. So force equal to dp into dp by dt. Change in momentum with respect to time. Same in rotational dynamics. Using some analogous terms, you just see. Already you discussed. I'm just also use some analogous terms here. What's the analogous terms here? Here you see that what I'm using is differentiating here this L angular momentum and inertia. I'm using an analogous term. Momentum and force I'm using an analogous term. I just changing these things. I just simply changing these things. So instead of force, what I am using here, torque. Torque equal to change in angular momentum with respect to time. That's another formula. You already know the force is change in momentum with respect to time. As like that, the moment of force, which is, as I already discussed that the torque, another name is moment of force, is change in momentum with respect to time. That's it. It's just an analogous term. Just exchange these terms, you will get the answer. So this is another formula. And another important thing, how the energy is conserved, the angular momentum also said to be conserved. Okay. So whatever that, the angular momentum is conserved. Hence, the initial angular momentum is equal to final angular momentum. That's I1 omega 1 equal to I2 omega 2. This is what it says. Hence, I into omega is constant. So it's never changes. I into omega it never changes for any questions or any cases. The angular momentum seems to be conserved. Now this may be changed when there is a ruling that we're going to discuss in our next topic. Okay, that's it. The angular momentum topic is over. Nothing more to be discussed.